I'm Sam with jbugs.com. We're in the midst of our 1971 Super Beetle engine rebuild. In our last video, we got the short block bolted together. With the engine taking shape, we can set the crankshaft end plate and install the flywheel, but we'll start by modifying our new oil pump to work with our full flow system. A full flow kit will allow us to run an oil line out of the engine from the pump, through a filter, then into an oil cooler if we'd like, and then back into our engine. Our new oil pump is a 26mm unit made for late model dual relief cases using a flat cam. We need to block off the stock exit port on the pump so that it will push oil out of the pump cover that will be installed later. We tighten the pump in our bench vise with rubber pads on either side so that the pump isn't damaged. The exit port is the upper left side of the oil pump as the pump would sit in the case, at the left of the oil pump drive gear hole. A 5/8 inch drill bit is used to open up the port in the pump for a threaded plug, and a 3/8 NPT tap is used to cut the threads in the port on the oil pump. With the threads cut into the pump, we test fit the threaded plug and note that it sticks out just a bit, so we unthread it and grind down the high portion with a sanding disc. A burr bit is used to clean up any rough surfaces inside the oil pump caused by drilling and tapping, and a scuff pad is used to clean up the outer diameter of the oil pump where we drilled and cut the threads. Don't take too much material off the pump, just remove any high surfaces. The threads in the plug are coated with red thread locker, and it's threaded down into the oil pump and tightened. The oil pump and gears are cleaned, and we check that the gears spin freely in the pump. Because we have a thicker than stock oil pump and an aluminum cover, the 4 stock oil pump studs are removed from the case. Then we thread a nut onto the stud and insert it through the pump cover and the oil pump, and mark how much thread on the stud is remaining. The stud is coated with blue thread locker and threaded into the engine case up to the mark that we had made. We measure how much thread is sticking out of the case and thread the other 3 studs into the same depth after applying blue thread locker. The inner oil pump gasket is coated with gasket cinch and slid onto the studs. It's followed by the oil pump. The pump gears are installed, making sure that the cam drive gear aligns with the cam shaft. The marks on the gears don't have to line up, just make sure they're both visible. The outer pump gasket is coated with a thin film of copper RTV and slid in place, followed by the oil pump cover, which is aligned with the output pointing to the left side of the engine. Oil pump sealing nuts are threaded onto the studs and tightened down to 14 foot-pounds, along with the 2 engine case nuts above and the nut and bolt below the oil pump, again to 14 foot-pounds. The threads on the barbed hose fitting are coated with blue thread locker, and the fitting is threaded into the pump cover and tightened down. Now, at the back of the engine, we set our new flywheel onto the crankshaft and tap it into place. A new chromoly gland nut is threaded into the crank to hold the flywheel in place and tighten down. Now our first specialty tool is brought out. We have a dial indicator with a magnetic base. They aren't too costly, and they will be used again later in our engine build. The magnetic base is used to attach the dial indicator to the face of the flywheel, and the flywheel is pulled or pried away from the engine. The dial indicator is set by moving the arms and tightening the set screws for the arms so that the end of the indicator is sitting against the bell housing of the engine. The fine adjustment knob on the indicator is turned so that we can zero out the end of the needle, and we can turn the gauge to zero out the dial. By pushing the flywheel back and forth, we can see that we have 44 thousandths of an inch of end play currently. When the end play is set, we want to have 3 to 5 thousandths of an inch. Aiming for the middle, we need to add 3 shims that together are 40 thousandths of an inch thick. The dial indicator is pulled off the flywheel, the gland nut is unbolted from the crank, and the flywheel on a dowel pin are marked so lining up the offset pin litter will be simple. The flywheel is removed, and we install 3 new cleaned flywheel shims, 2 0.34mm and 1 0.36mm, which will give us about 40 thousandths of an inch onto the crank. Then we reinstall the flywheel and tighten the gland nut while using a flywheel lock to prevent the flywheel from turning. The dial indicator is set in place and zeroed out again, and we pull the flywheel back and forth, and we see that we have 3 thousandths of an inch, which is in spec, so we can pull the flywheel off one last time and install a lubed O-ring into the groove on the flywheel. At the engine, a new rear main flywheel seal is lubed on the inside diameter and pressed into the engine by hand at first, and we follow that up with a flywheel seal installation tool, which is tightened to push the seal all the way into the engine case. The seal should be recessed slightly from the surface, not flush with the case. The tool is unthreaded. The flywheel is set back into the crank again. The gland nut is threaded into the crank, and a flywheel lock is slid onto the lower engine stud. And a torque wrench is used to tighten the gland nut to 26 foot-pounds, or 235 foot-pounds if a torque tool isn't being used. We like the torque tool as it doesn't require bracing the engine and stand to tighten the gland nut. With the gland nut torqued, we check the end play one more time to verify the end play is in spec, and we'll take a break here until our next video. There we'll start the assembly of our top end and install the head studs, test fit our pistons and cylinders, CC our heads, and set up the compression ratio for our engine. Thanks for watching, and in the meantime check out some of our other how-to videos, or head over to jbugs.com for all your vintage Volkswagen parts and accessories.